Hello and welcome to today's class. Let's proceed in the solving of other example in the idea of a differential equation under integration method. I think this should be the fourth example that we'll be trying to evaluate using the idea of a differential equation under direct integration method, right? So let's see how we can solve this particular question. First things first, what do we know? Your first task is what we know is that you will take the x to the other side, right? That's what we said. We said um, ensure that what's it called there? We said ensure that all the terms are in terms of x. So everything here in terms of x. I have the power of the x equal to everything here in terms of x. This man is the direct integration method. So it's a direct integration method. So this is the first thing to put in place. Next task is that first is first. To solve this one here, you said normal concept. Take the s here. That gives you dy is equal to x ln x squared plus 1 all over x squared plus 1, then attach the x to it, the x this way. All right, I have this. We said take the x to the other side. Your next task now is to integrate through. All right, integrating through, integrating through. Right, that gives you the integral of dy is equal to the integral of x ln into x squared plus 1 all over x squared plus 1. I have the x here. All right, I have this here. So integrating through, I have this expression. What's your next task? My next task is to look for a way to integrate this stuff here. Normally, if I integrate the y, I will have y, right? We know that. But how do you possibly integrate this one here? How do you integrate this? So think, what do you do here? What method do you apply here? Is it by part, by partial fraction, or what do you call it? General method or substitution? What do you do here? Of course, my first priority is to use substitution method, right? So let's say from here, I have to solve this one here. So my task is to let you, so let's work on this. So let me call u to be equal to x squared plus 1. It means that du over the x is equal to 2x. If I differentiate x squared, I have 2x. 1 is a constant term, that's 0. U the x is 2x. Make the x subject from here. I have that the x is equal to du over 2x. All right, just swap. The x comes here, 2 over x comes down here. That gives you du over 2. This the x comes here. So I have this here. From here, substituting. Mind you, I still have this one written down. So the integral of dy is equal to, this one gives you integral of x ln, we just said x squared plus 1. This one here should be u. Ln u all over u, x squared plus 1 should be u. This u dot dx. Dx now is u over 2x. That's du over 2x. What do you observe here? This x will cancel this x here. This one gives you the integral of dy is equal to integral of ln u all over u dot, sorry, I have 2 here, so that gives you du over 2. All right, I have this, please. I have it here. So the next task here is to bring out this half, this 1 over 2, bring it out. So that gives you the integral of dy is equal to the integral of, this one can be written as 1 over u dot ln u, right, dot 1 over 2 dot du. Dot du. Observe, this u can be shifted out. That 1 over u dot this one ln u should be here. 1 times ln u still gives you ln u over this u. Still the same thing. Apply the same thing here. Shift out half. This 2 out. That gives 1 over 2. This du should be here. So 1 times du gives you du over this same 2. So they're still the same thing. Right? So this constant term, 1 over 2, should come outside the integral sign. That gives you the integral of the y is equal to 1 over 2. This one here should come outside. So I have integral of what? 1 over u dot ln u, of course, with respect to du. Alright, from here, I'm trying to solve this one here. If you observe that, if I want to integrate 1 over u dot ln u, I'm having two terms here. Whenever you're having two things multiplying, when it comes to idea of differentiation, if I have two things multiplying, what method will we apply? I'll apply what? A product rule. So for integration, if you have two things that are multiplying together and you want to integrate it, what do you apply? You apply by parts. We call it integration by parts. The other method on integration called integration by parts is this method I will apply in this case. So I'm having this one here. So to make it more easier, most of us are familiar with using x. No, it was u and u. So some people get confused using u and u. So let's go back to normal s. I'll write out this question out, this one alone, and we'll solve it. Whatever we have as our answer, we'll plug in here and we'll proceed. So most of us are familiar with using x. So I'll change this u to xx, and then whatever answer we have, we'll plug in there. Right? So let's try to solve this one alone. So ln 1 over 2 dot, of course we know that if I integrate the y, here gives you y equal to 1 over 2 into, please integrate 1 over 2, 1 over u dot ln u. Let's see what we'll get. So I'll take this part down and solve it personally here. So I'll take this part down. Let me show you the process. Alright, so let's say I'm bringing out the integral of 1 over x dot ln x. Alright, with respect to the x. So I change all the u here to x because we're familiar with the idea of using x, right? So let's see what we can get here. So here's the idea, please. This is a question under integration by parts. When you have two to multiplying, don't use product rule. Use what the by parts. When it comes to differentiation, when they're multiplying, two are multiplying, use product rule. But integration, you use what? By parts. So what to know is that from by parts, using by parts formula is given as the integral of u dv equal to u dot v minus the integral of v du. This is the formula for by parts, right? So this is integral of u dv equals to u dot v minus the integral of v du. This is the formula for calculating by parts, right? So let's see how we can possibly use this stuff here to find the answer to this. The integral. So let's see. First, I'm going to comparing. Compare this one with this. Integral is integral. So u and dv. If you check our video on integration, I told you which term should be having u, which term should be having dv. I said usually u terms are always terms with log function, either log function or ln function or exponential function. They should always bear the u. So in this case now, u will take what? The ln x. So I'm saying that u is equal to what there? Ln x. If I differentiate u, that gives you du. Now observe, this is, we said u is this now. What of the v? The v will not take the other one. That's 1 over x. I'll use this the v to get v. So I need four things. I need u, I need the v. I need v, I need u. So all right, from here, so I'm using this formula to solve it here. So we're saying compare your question with this one here. So u is with this. I explain why u always take log function, lim function, exponential function goes with u. So u is going with this now. So this one here is u and this is it here. Why the v goes with this automatically? 1 over x. I'll use u to get the u. I'll use the v to get v, right? So if I'm having u as this, to get the u, it means I'm differentiating, right? So differentiate on a ln x, that gives you 1 over x. Differentiation, yes. Differentiate ln x, 1 over x. Now, if I'm having the v is like a differentiated answer, 1 over x. So to get v, all I do, I will integrate dv 1 over x. To get v, I will integrate. If I integrate 1 over x, that gives you what there? A ln x. I have this place. From here, put your values here. That gives you the integral of u dv. What's u? Ln x. Ln x dv is, of course, dv 1 over x. 1 over x is equal to, if I integrate this thing now, this question, because this one, it was ln x that was coming forward, 1 over x is this. They are still the same thing, right? If I say 2 times 3 and 3 times 2, you still have the same answer. So whichever way I arrange them, they'll still bear the same thing, right? So from here, proceed from here. If I integrate this stuff here, my answer gives you u. What's u? U is ln x. That gives you ln x dot, what's v? V is under ln x, then minus the integral of v. V is ln x. That gives you ln x dot du. It gives you 1 over x. 1 over x. If I integrate ln x dot 1 over x, that will give me ln x times ln x gives you ln x all what there, all squared minus integral of what? Ln x dot 1 over x. Right? I have this place. But observe that I'm still having under integration of what? Ln x dot 1 over x again. So observe that if I only integrated ln x or 1 over x, I had this answer. The answer again is producing out that same question I have again. This is case under cyclic integration. So this and this now are more of like the same thing. They are similar, right? See, this and this are similar. What do you do now? You now apply a concept. What concept do you apply here? I'll say let integral of ln x 1 over x should be I. So let's say, okay, from here, so I'll take this part off. So from here, I'll say that, so let I to be equal to the integral of, that thing that is repeating, that's ln x dot 1 over x. So if I is this, it means from here I will have that I is equal to ln x all squared minus under I. Take this I here, that gives you I minus I comes, becomes what? A plus I equals ln x all squared. I times I, of course, gives you 2i. So 2i is equal to what there? Ln x all squared. From here, let's make I subject. If I make I subject, that gives you I equals ln x all squared all over 2, making I subject. That goes by 2. You have this, right? So, but what's I? I is what? So, if I means integral of ln x dot 1 over x is now equal to ln x all squared over 2. So it means if I integrate ln x 1 over x, that gives me ln x all squared over 2. So it means that if I integrate ln u and 1 over u, my answer becomes what there? Ln u squared over 2. This one is a term of x. So the answer should be what in terms of u. So if I integrate 1 over u dot 1 over, if I integrate ln u 1 over u with respect to the u, I should be having what? Ln u all squared over 2. So my answer gives you ln u, right? Ln u all squared over 2. All right. Of course, plus c, concept of integration. From here, this one gives you y is equal to 1 times ln u all squared. That gives you ln u all squared all over 2 times 2 gives you 4 plus c. But what's this u? But what's u? What is u? I think u is x squared plus 1. So u is x squared plus 1. Oh, I've erased it. U was x squared plus 1. So let's put in u value here. So from here, my answer becomes y is equal to ln into what's u? U is x squared plus 1. Then the square comes here, your plus c all over. This gives you 4. This is the answer to that direct integration you have seen on the board. This is a solved problem of this nature. So hold on a bit. Let me show you something, please. This 1 over 2 was here, right? So I need to put this in a bracket this way, such that 1 over 2 multiply this, that gives you this, plus 1 over 2 times c, that gives you c over 2, not just c. So there should be an over 2 here, c over 2. All right, because there should be a bracket, because r1 over 2 is constant here. If I integrate this one here, I'll have this expression. It should be in a bracket, right? So use half to multiply this one, you have this. That same half to multiply c, you have this. And this is how your final answer looks like. So this is how you solve problems of this nature using direct integration method. Next class, look at variable separable method.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, WAEC/JAM student, WAEC/JAM classes for JAM students, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.